All right. Today we begin chapter 3. And we will continue the process of building on the foundation principles that we've established so far. Today we're going to be exploring lines and angles, and we're going to start with what we already know and today's warm-up. So you were asked to find the measure of angle 2, the measure of angle 3, measure of angle 4, and measure of angle 5. What did you get for the measure of angle 2? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 confident people. We'll start with Stephanie and then Kamoy. What'd you get? Okay. Angle 2 is 37 degrees. What about angle 3? Start with Valerie and then Eric. Angle 3. 90 degrees. What about angle 4? Start with Nathaniel, then Ziumara. 53 degrees. And what about angle 5? Start with Alexandra and then Caitlin. 37 degrees. Very good. Give me a thumbs up if you got all of them correct. Good. Put your thumbs down. That was a lot of you. Now, if I asked you to find them in order, in other words, I asked you to find the measure of angle 2 first, what idea, property, theorem, postulate, what could you use to support the fact that angle 2 is going to be 37 degrees? Again, if I asked you to find this first from what we are given. Could you? The angle addition postulate. The angle addition postulate, and you would use it how? Okay. Okay, but you said a whole bunch of other stuff beyond the angle addition postulate. Let's focus on the angle addition postulate. What does the angle addition postulate say? Okay, that's sort of what it says. Angle addition postulate has to do with adjacent angles. So in this case, we have two adjacent angles. Here, let me modify the picture for you so that you could see it a little bit better. What you're saying, I think, is that, right? Those are adjacent angles. We know angle 1 is 53. Angle 2 is adjacent to it. So by the angle addition postulate, adding them together will equal the whole, but you're missing something. What's the piece of information that he's missing to make this work? Kamoy? Yeah, and what is it equal to? And how do you know that? That's right. Since this is a straight angle right here, and this angle is 90 degrees, that means this angle must be 90 degrees because of the definition of a straight angle and the angle addition postulate. And so we have a whole bunch of different ideas going on in here. Okay? So you needed to know that this was 90 degrees. And then by the angle addition postulate, angle 1, the measure of angle 1 and the measure of angle 2 will add up to 90 degrees. Very good. Anyone have any comments, questions about that? Okay, if we continue going in order, and I ask you to find the measure of angle 3 next, what property, definition, postulate, theorem could you use to support the fact that angle 3 has a measure of 90 degrees? Stephanie? You remember the whole thing? Nathaniel? You're missing one word. Ziumara? The vertical angles congruence theorem. this angle and this angle are vertical angles. And the vertical angles congruence theorem says vertical angles are congruent. Since the other one was 90 degrees, this one is 90 degrees. Very good. Anyone have any comments, questions, or concerns about today's warm-up? Anything at all? Good. So again, we are entering into chapter 3 and we're going to be exploring angle relationships and what happens when we have lines cut by other lines, and we have a lot of different things that we're going to be exploring. Today's going to be all about laying foundation, laying basic ideas down so that when we get to the more complex ideas, they will make sense. So, our objectives today are to identify parallel, perpendicular, skew lines. I think you should all be familiar with parallel and perpendicular, but skew, I would imagine, is new. Identify angles formed by two lines and a transversal. You're familiar with what a line is. I'm not sure if you're familiar with what a transversal is. And so when I say laying foundation, what I mean really is vocabulary. Now, I don't need you to copy this yet, but you are going to be introduced to all these terms today, and you will become fluent in them, so that next time I see you, it will be effortless to understand alternate interior angles and what it means. The last vocabulary term, same side interior angles. That's what it's called. The publisher in the textbook calls it consecutive interior angles. They are interchangeable. So you're going to have to catch on to the fact that the publisher's calling it one thing and it means something that's the same but a different name. Okay? Any comments, questions so far? Good. So let's go ahead and start working. Now, I don't need you to copy everything here, but there's a few things that you do not know, as I had already indicated. And so we need to start learning what these terms mean so that we can speak to each other, communicate, and actually utilize the ideas. The other ideas that are coming out of this are symbols. So you've got some symbols in different places. For example, parallel lines are indicated by a double vertical line, and that's not an 11, so you have to make it look like something different than an 11. And you see it here and here, indicating that line AB is parallel to line EF. You also see in the picture here that we have these arrows. When you have an arrow on, arrows on lines, that is indicating also that they are parallel to each other. If you have a picture that has more than one set of parallel lines, you have to use double arrows and maybe even triple arrows to indicate other sets of parallel lines. So that's one set. Here is another set of parallel lines, here and here. That's a double arrow on both of them. That way you know that this one is parallel to this one, and this one is parallel to that one. Any questions about the symbols for parallel? Okay, perpendicular. You already know what it means. This symbol means perpendicular. So line AB is perpendicular to line AE. So these are all ideas that you already knew. Now the idea of skew. Skew are lines that are not coplanar, and they're not parallel, and they don't intersect. For those of you who just know that lines that never intersect are called parallel, might be thrown off by this idea, and when I started exploring the idea, I also got thrown off by it a little bit. If two lines never intersect, then that's called parallel, right? Well, this idea exists in three-dimensional space. Skew lines only work in 3D. So let me show you an example of skew lines. We're told that line AB and EG are skew. So line AB here and line EG here are skewed. They will never touch, but not because they're parallel. They will never touch because they're not coplanar. And so in essence, you need to have one line kind of going horizontally and one line sort of going vertically, okay? Or something to that effect. And so again, this only works in 3D because if I were to bring this line back here, well, that would be perpendicular. And they're coplanar because they're in the same plane. But when we move it up here, they are no longer coplanar, and they'll never intersect. And that is skew lines. Any questions about that? And lastly, parallel planes. And if you take the idea of parallel lines and extend it to the idea of a plane, you should be able to figure out that parallel planes are two planes that will never intersect. So we have indicated ABE and CDG. So ABE and CDG. Does anyone have any questions about the terminology? Okay, so now we're going to build from here. The next page, I'm going to show you a bunch of angle relationships. I don't want you to start copying. I want to discuss with you what they mean, and then I have an idea of the best way to get all the information down in a simple way. So, oh, I apologize. I forgot about the postulates. My fault. So, from the ideas of parallel and perpendicular, we have two postulates, and I apologize. You do need to know these, but they're quite simple. If you have a line and a point not on the line, there is exactly one line through that point that will be parallel to the given line. So, for example, I could draw this line through point P. I could draw this line through point P. I could draw this one. I could draw this one. There are infinite lines I could draw through point P, but there is only one line through point P that will be parallel to line L. So that's the point of the parallel postulate. There's only one line through a point that will be parallel to this other line. Likewise, there is the perpendicular postulate, which says almost the same thing. If we have a line and a point not on the line, there's going to be exactly one line through that point that will be perpendicular. So again, I could draw all these different lines through point P. But only one of them will be perpendicular to line L. Does anyone have any questions about the parallel postulate and perpendicular postulate? Okay, so take a moment to jot down the postulates. Again, use lots of abbreviations to help yourself. Just take another 30 seconds to a minute. All right, if you're missing any of this, this will be on my website. It's in the book. You've got lots of different places to find it. So I'm going to keep going. Leave a couple of lines of space if you need to fill something in. And so now we are ready for the big major ideas. These angle relationships, they're referred to as angle pairs. So I don't want you to get too overwhelmed, and I don't want you to copy yet. I don't want you to copy anything. In fact, we could probably get away with not copying very much, but we need to learn. So let's learn first, and then we'll figure out how to make it, condense it onto the paper. So today we're going to talk largely about the idea of having lines in space, and then a line cutting across them. The line cutting across them called the transversal. So here's a picture that we're going to use for every single term. So we have two coplanar lines. That's these two lines. In this case, they are not parallel. They are just two lines. And then we have this third line cutting across them. That's called the transversal. When you cut across them with this transversal, 8 angles are just created. They're numbered, 1, 2, 3, 4, 5, 6, 7, 8. There are different relationships with the different angles. Does anyone have any questions so far? So that's transversal. Any questions? All right. So from there, we have something called corresponding angles. Corresponding angles is a pair of angles that are on the same side of the transversal. So when I say on the same side, I am referring to that's all on the same side. Okay? 1, 3, 5, and 7 are all on the same side. Likewise, 2, 4, 6, and 8 are all on the same side. So corresponding angles are on the same side, and then they're on the same sides of their respective lines, R and S. So, for example, corresponding lines we have right here is angle 1 and 5. Angle 1 and 5 are both on the left of the transversal, and they're both north of their respective lines. So they're both north. Okay? Those are corresponding angles. 3 and 7 are both on the left side of the transversal, and they're both south of their respective lines. So they are corresponding. 2 and 6 are both on the right side of the transversal, and they're both north of their respective lines. They are corresponding. And then 4 and 8 are both on the right side of the transversal and both south of their respective lines. They are corresponding. So from this picture, we have 4 pairs of corresponding angles. Anyone have any questions about corresponding? Okay. Alternate interior. Alternate interior angles are on opposite sides of the transversal, and they're on the interior of the picture. They're on the interior of the picture. You can see that we went ahead and labeled this the interior. This is the interior. This and this constitutes the exterior. Alternate interior angles. So we already see that 3 and 6 are alternate interior. They're on opposite sides of the transversal, and they're on the interior. 4 and 5 are alternate interior angles. Does anyone have any questions on alternate interior? So let's pause for a moment. So what I would like you to do is I would like you to draw your own version of this picture. And we're going to start putting in some of these ideas. Instead of writing them as definitions, let's actually just draw some arrows and write the terms with the arrows to indicate them. So you could write that angle 1 and angle 5 are corresponding angles, and you can just kind of indicate that somehow. And alternate interior angles, you can see that 3 and 6 is one example, 4 and 5 is another example, and you can indicate that somehow. So take a moment to draw your own version of the picture. Should be close. Make sure you put the numbers in the right place. Okay, so now that we've got a way of incorporating this information together, we've already covered transversal, corresponding angles, alternate interior angles. Now, alternate exterior angles. Based on what you've learned from alternate interior, you could probably figure out what alternate exterior means. Opposite side of the transversal on the outside of the two lines. So angles 1 and 8 are alternate exterior because here they are. Opposite sides of the transversal on the outside. And the last angle pair relationship is called same side interior. You can figure it out just from the name. As I indicated, that the publisher calls them consecutive interior. Same side interior angles are on the same side of the transversal and on the inside of the picture. So angles 3 and angle 5 are same side interior angles. So this is the foundation for what we're going to be doing for the next week or so. And then beyond, of course, but what we're going to focus on. Does anyone have any questions about this terminology? So you're going to become fluent in these. You're going to have to be able to say out loud, oh, Mr. Galloway, alternate interior angles, oh, those would be angles 5 and 4. You have to be able to say it, okay? Any questions or comments? Okay, so let's start putting this into practice. So example 1, I do not expect you to draw the picture at all. I decided to pick a picture that sort of had some real elements to it. It's supposed to be a rectangular prism made out of playing cards. So you can see the little images from the playing cards within the picture. But that's not really the focus. The focus is the different things that come out of this. So we would like to be able to identify all of these different things. Parallel segments, skew segments, perpendicular segments, and parallel planes. You see a lot of indicators all around the picture. A lot of indications of right angles and parallel lines. So you want to focus on those. So let's start with a pair of parallel segments. We can do this together with your input. Pair of parallel segments. Give me one. Nobody can give me a pair of parallel segments? Oh, we have a bunch of people who can. So we'll start with Alexandra and then Stephanie.
Segment RM and segment SM.
Okay, so segment RM right here. And segment SN right there. It's a pair of parallel segments. It's clearly labeled right there, right there. Stephanie?
Segment NK and segment ML.
Segment NK and segment ML. Parallel segments clearly labeled right there. Any others? No others? Can't find anything? Sebastian? Segment SP and segment RQ. Clearly indicated right there. Kamoy? Segment PK and what? Segment QL right here. Absolutely. So does anyone have any questions on how to identify a pair of parallel segments? So let's make sure we can write it correctly. You have to write segment, so it's got to be like this. And segment NK is parallel to segment ML. Any questions about that? Okay, part B, a pair of skew segments. So here's what I'd like you to do. I want you to write down a pair of skew segments. You just write it down yourself. Give me a thumbs up if you got a pair. Good. Put your thumbs down. Dianara, what's yours?
Segment SN and KL.
SN and KL are skew. Very good. And so I'm going to call on a few more, but how do you write that? You write segment SN and segment KL are skew. There is no symbol for it. Okay? Good. And give me another pair of skew. Another pair. Nathaniel?
Segment ML and PS.
Segment ML and PS. Hold on, let me get rid of this. Segment ML and PS, unfortunately, are not skew because they are parallel. So this takes a little thought, and you know, I don't blame you. First time I went through it, I had to go through it a bunch of times till I understood. So unfortunately, those are not skew because they are parallel to each other. we could draw a plane through them diagonally. So they are coplanar, okay? So, unfortunately, you're going to have to erase what you wrote and change it. Can someone give me another one? Kamoy? RM and PQ. Absolutely. The picture's a little bit messed up because it looks like they're crossing, but you can tell from the three-dimensional picture that PQ is behind RM. So she's absolutely right. Any other ones? Alexander?
Segment SR and segment
SR and QL. Very good. Does anyone have any questions about skew lines? All right? No questions? All right, perpendicular. I want you to pick a pair of perpendicular lines and write it down. Okay, give me a thumbs up if you have a pair of perpendicular lines written down. Oh, a bunch of people still writing. Okay, I'll ask you again in a moment. Good. Stephen, what's your pair?
Segment NK is perpendicular to segment KL.
That?
Yeah.
Okay. What tells you that they're perpendicular? I'm sorry?
Nothing. It doesn't show that square.
Okay. So, yeah, it doesn't have the indication like it does down here. Now, he's right. They are perpendicular, but we would have to actually prove it. And we would have to prove it by using postulates and theorems that led us to understand that because this is 90 up there, and then that's 90 over there. But we don't have an indication in the picture right off the bat that they are perpendicular. He's right, but we want to try and use what's in the picture. So does anyone have one that's based on the information in the picture? Ziumara?
segment P is perpendicular to segment
This is perpendicular to that. That also doesn't really have an indication, but she's right. This indicator right here is for this line going this way. Doesn't really indicate it going the other way. So we are making some assumptions. She's probably right, they are perpendicular, but it's a little tough to call based on the information in the picture. Kamoy and then Kadir. RM and RQ are absolutely perpendicular because of that indication right there. Kadir and then Valerie. SR and RM are absolutely perpendicular. Very good. Valerie. NS and SR, absolutely. NS and SR, very good. Any questions about identifying perpendicular lines? So how do you write it? If we're talking about segments, we've got NS, segment NS is perpendicular to, it's an upside down T, NS is perpendicular to SR. Anyone have any comments, questions? All right, in a pair of parallel planes, can you name a plane? Name any plane that you can see. How do you name a plane? Only two people know how to name a plane. Sharik, go ahead.
You name a plane by saying three non-collinear points that are on that plane.
Okay, good. So can you name one for us?
On this plane, KLM.
Okay, so KLM is right here. KLM is that plane right there. So what would be the parallel plane to that? What would be the parallel plane? Eric? SQR. Oops, excuse me. I didn't do a very good job, but SQR, and so those are parallel planes. And so how do you write that? There's no symbol for plane, so you just write the word plane. And we could call it KLM is parallel to plane. And we can say SPQ. So does anyone have any questions about naming the different objects? Any questions, comments, or concerns? Okay, so give it a shot on your own. You do not have to copy anything. You just need to provide me with the information. Identify each of the following. You've got 4 questions. It's okay, keep going. I know you're still finishing. 1 minute wasn't enough. Okay, so give me a pair of parallel segments. Pair of parallel segments. We've got number 8, 9, 14, and 16. Number 8, give me a pair of parallel segments. What was the second segment? Okay, good. Number 9. Okay, number 14. Nobody? And number 16. Very good. So I had segment BF is parallel to EJ, segment EJ, but every single one of them that has been said is correct. Anyone have any comments or questions, or a different one that they want to share? Good. What about part B, a pair of skew segments? Pair of skew. We've got numbers, how is that possible? We got number 7, 16, and 21. Number 7, what'd you get? Segment CD and R skew. Okay, and number 16 again?
Segment
Very good. And number 21.
Segment
Very good. So those are the ones that's the one I said. Segment BF and CD are skewed. Very good. What about perpendicular segments? Someone give me a perpendicular, pair of perpendicular segments. We got Valerie and then Stephen. Valerie. Okay.
Segment BF perpendicular to segment FJ.
Okay. Segment BF is perpendicular to segment FJ. It's really the only one indicated on the whole picture. We could probably make an assumption that the other ones are perpendicular as well, but it's not indicated. And for a pair of parallel planes, let's see who's able to say it correctly. How do you say it? All right, let's get some people. And so we've got numbers, 15, 16, and 19. Or 15. EGH. EJH, okay, and?
F plane FBC.
Okay, good, those are parallel. And number 16? Very good, and number 20, who was the last one? Number 19?
Plane B, C, D, and plane F, G, H are
Okay, FGH, okay. So I had plane FJH is parallel to plane BCD. Anyone have any comments or questions on identifying these different ideas? Good, so again, we've laid the foundation, now take it a step further. And example 2, let's talk about these different pairs of angles. So you're going to need your own version of this picture, and then we're going to identify an example of corresponding angles, alternate interior, alternate exterior, and same side interior. So corresponding are on the same side of the transversal and in the same location with respect to their lines. So let's see what we figured out already. Can someone give me a pair of corresponding angles? Stephen and then Alexander.
1 and angle 5.
Angle 1 and angle 5. Alexander?
Angle 3
Angle 3 and
and angle 7.
angle 7. Very good. Any other ones we can pick out? Only the same people can do that. Can pick out another pair of corresponding angles. If you're having trouble focusing, just try to lift yourself up a little higher in your chair. Stephanie?
Angle 4 and
Angle 4 and angle 8. Very good. And what else? Sebastian? Angle 2 and angle 6. Very good. When we have two lines cut by a transversal, we will have 4 pairs of corresponding angles. Any questions about that? Good. What about alternate interior angles? Let's see what we figured out already. Think about the name and think about where they would be. Okay, Sharif?
Angles 4 and 5.
Well, angle 4 and angle 5 are on the same side of the transversal, and alternate means on the other side of the transversals.
4 and 6.
4 and 6. So angle 4 and angle 6 are alternate interior angles. And what's the other one, Nathaniel?
Angle 5 and
Angle 3 and 5. Very good. And when you have two lines cut by a transversal, there will be two pairs of alternate interior angles. What about alternate exterior? Give me a pair of those. Sebastian? Angle 2 and angle 8. Very good. Angle 2 and angle 8 are on opposite sides of the transversal and on the outside of the two lines. Very good. Kamoy? Angle 1 and angle 7. Very good. And with a picture like this, we will end up with two pairs of alternate exterior. You had a comment or a question, or the next one?
Yeah.
Next one?
See.
I'm sorry? Next one? Okay. Same side interior. Go ahead, Sebastian, and then Steven. Sebastian. Angle 3 and 6. Same side interior. Same side of the transversal on the interior of the image. So angle 3 and angle 6. And Steven?
Angle 4 and angle 5.
Angle 4 and angle 5. Very good. Anyone have any comments or questions? Any problems, any concerns? Okay. See how you do on your own. I just need one example of each. One example of each. You got 2 minutes. All right, colored pens, let's see how we did. The corresponding angle that I chose was angles 1 and 3. Then we're going to have different pair. Kayla, what was your pair? Angle 5 and 7 is corresponding. Give me another pair. Come on. That is another pair of corresponding. There's one more, Valerie. Angles 2 and 4 are corresponding. Very good. Part B, alternate interior. I had angles 3 and 6. What's the other pair? Sebastian? Angles 2 and 7. Alternate exterior. I had angles 4 and 5. What's the other pair? Stephen? Angle 1 and 8. Same side interior. I had angles 6 and 7. What's the other pair? Kadir? Angles 2 and 3. Does anyone have any comments, questions on how to identify these different relationships? Any concerns? All right, draw a line across your paper indicating the end of today's new lesson. Your homework is on page 142. You're doing numbers 3 through 27. That's 25 questions. Then you're going to read the next section or do the at-home tutor. And you're going to have a quiz next week. And that will be on 3.1 to 3.2.